class with me. Today we'll talk about probability, and we want to solve these probability problems using a lattice, or sometimes called a sample space diagram. This diagram is going to be different textbook write it differently, but the concept is actually very simple. Now imagine here we have 5 cards with these numbers on it, right? And these cards are going to be shuffle, 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 and then you pick one card at random. And then you look at it, right? And then you say, oh, 3, then you write down number 3 there. And then next, you put the card back into this pack and you shuffle, shuffle, shuffle again. So this is what it means by with replacement. And then you pick another card. So every time you pick, that you actually have 5 cards from a deck that you are picking from. And then you take the second card, and then you look at the card, oh, 3 again, and then you write down 3, for example. So here the probability, we are asking this question, find the probability of obtaining an even sum. Right? Obviously you can do a listing for this problem, but it's easier if we consider this. That is, here is my card 1, here's my card 2, and here are 2, 3, 3, 4, 8. I'm listing out all the possible cards here. Here's 2, 3, 3, 4, 8. I want an even sum. That means I need to add them up together. Card 1 and card 2. So for example, a dot. Because this is with replacement, it is possible to get 2 first, 2 from the card 1 and 2 from the card 2. So then I have 4. Here, 2 plus 3, 5. 5. Here is 6, 10. And then find even sum. So I just have to figure out which of these are even. Well, that's 1, that's 2, that's 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Right, let's make sure that we get everything. Count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So now I'm going to identify the case where the first card is more than the second card. So all this first card is more than the second one, and the first card is more than the second one. 4 is more than 3, 8 is more than 3, and so on. 4, this one, and 8, nothing is more than 8. They are the same. So how many possibilities do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9, so probability for the 25. Here you can think about, we have 5 cards, and these 5 cards, you shuffle, 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 and you pick one card at random, look at it, oh, that's 0. And you happily write 0 down, and then that card that you have already picked, you put aside, that is means without replacement, and then now you have 4 cards, shuffle, 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 and then you pick another card and look at it, oh, now it's 2, and you write it down, right? So what we want is to find the probability that you have an odd product. So then you have that card 1 here, and then card 2, the value of card 1 and the value of card 2, and then now you put in the value. So here I will multiply 0, 1, 2, 2, and 7. 0, 1, 2, 2, and 7. But the thing in the diagonal cannot happen, so we have to take that out. So the dot means doesn't exist, because you can have card 1 being 0 and the second card being 0 again, because this is without replacement. So now we put in the values, multiply together. So anything multiplied by 0 is going to be 0. Right. 1 times 2 is 2, 2, 7. Here will be 2, 2, what we have. And we want to find the odd product. Which of these are odd? Well, I see a 7 here, which is odd. And I see a 7 here, which is odd. 0 is neither odd nor even. So here the answer to this problem is the odd product. It's just going to be 2 out of 20. Because there are 20 possibilities, the diagonal is not included.